Hello and welcome back to the third and final video on section 6.1 on the normal distribution, in particular the standard normal distribution. And what we'll do this time is, instead of being given a z-score and finding an area, we're going to take an area and turn it into a z-score. So from here, what we'll do is we'll look at, okay, so we've got our normal distribution and we have some value for z such that the area to the left of that value is 0.9207. So the question is, what is z? Well, from before we had to use our calculator or our table, so we'll just have to do the same thing again. So if I come back to what an example problem might look like, here it says find the indicated z-score, so it tells us, oh, here's z, the area to the left of z is some number. Not the same number that I had in my question. The first place that I would go is question help and then StatCrunch. And when I open StatCrunch, there will be the calculator under statistics, and we can look at the calculator for the normal distribution. So again, to make sure that everything is correct, we want the mean to be 0 and the standard deviation to be 1, because this is the standard normal distribution. And in my original question, I asked, okay, this area to the left here is going to be 0.9207. So what I'm going to do is I'm going to say that the area to the left here is going to be equal to 0.9207, and when I ask it to compute it, it will tell me what the z-score is. So if I round, this is going to be 1.41. So this z-score here is going to be 1.41. Now, we could also try to find the z-score that we're given the area to the right of that as well. So here I can take this curve, and instead of looking to the left when we're looking at values that are less than it, we'll look at values that are bigger than it, and we have to give it the correct value for the area. So this area is going to be 0.3372. So let's type that in. The area to the right now is 0.3372, and when we compute it, we get 0.42 if I'm rounding to do 2 decimal places. So z here is going to be 0.42. And we can find our z-score. We can also use the table instead if we want. So instead of using our nice calculator, and we go back to looking at this, how they would have did this a long time ago, we can come back and we can look at tables. So the first thing that I'll notice here is that this area is more than 50%. And if you remember from last time, this is poorly drawn, but anyway, 50% of the area is going to be to the right of the middle. So this is going to be 0.5. So since this is bigger than 0.5, I know that my z-score is going to have to be positive, because it's going to be to the right of 0. So that just gives me a little bit of knowledge. I know that it's going to be a positive number, but I don't know which one. So when I come back to my tables, the first table only has negative z-scores in it, so I don't want that. When I come to table 2, this will have positive z-scores, and what I need to look for is the area is corresponding to 0.9207. So as I come down here, I see, oh, here is 9207. So the first two digits are 1.4, and we're in the second column, and that corresponds to the second decimal place being 1. So 1.41. So again, we found the same answer that way as we did here, 1.41. Likewise, down here, I can try to find this area, which is 0.3372. Now, the thing is, these tables, if we want to use them, only describe areas to the left. And when I look at this graph, this area is to the right. So off the bat, I can't use that table directly. I'm going to have to do a little trick. And the trick is, this is symmetric. So if I were to take the normal distribution and flip it over, so instead of looking at the area to the right of this guy, I can look at the area to the left of this. Now, if the middle is 0, and we've flipped this across, this z-score is going to end up being the negative of the one that I want. Whereas over here is positive, over here is negative. I've just taken this, and I've taken this positive value, and I've flipped it across to be the negative value. So this area and this area are the same. So all I have to do is look up this, and when I find it, it'll be negative, but I'll just unnegate it to find the actual answer. So when I come back, I'll need to be finding a negative number. The probability that I want is 0.3372. So 0.3372 is right here. And this is going to be 0.4, so negative 0.4. 2. 2 is going to be the second decimal place. Oops. And yes, this z-score is negative 0.42, but we know that it's on the wrong side. We want to flip it over, so we negate it to find z is equal to 0.42 instead. So we can look up the z-score from the area. If it's to the left, everything works fine. If it's to the right, and we're using the table, there's an extra step, but it's not too complicated. And the very last thing to mention in this chapter are what are called critical values for z. And the critical values of z are just these numbers here. And the reason why these are called critical values is these are kind of the cutoff points for what we would consider common z-scores. So with a z-score of 1.96, if we look above that, it's a pretty small area. And if we look below negative 1.96, this is also a pretty small area. And in fact, these areas are going to be 0.025 and 0.025. So a z-score bigger than 1.98 has a probability of occurring 2.5%. So only 2.5% of the time, which I believe is 1 in 40, you'll get a z-score of bigger than 1.98, and you'll get a z-score of negative 1.96 of negative 1.96 only 2.5% of the time, and that's considered unlikely enough that those would be significant. So if you had some sort of distribution that was distributed normally about 0 with a standard deviation of 1, these z-scores are kind of the cutoff for what would be normal z-scores. Anything between normal, anything beyond them would be considered unusual.